Hello students, it's a physics class and today we will discuss about some special cases of the relative velocity. We have to do some problem. For example, if a man is walking in the rain, in which direction he should have to take umbrella to protect himself from the rain. Secondly, a man is swimming and crossing the river. At what angle he should cross the river, or what is the time taken by the swimmer to cross the rivers. These are the special cases of the relative velocity. We will do some numerical based upon these topics. Let's start. In the order to find the angle at which the umbrella should be held to protect himself from the rain, we have to find the relative velocity of rain with respect to the moving man. Suppose rain is falling vertically downward and man is moving forward horizontally. To determine the relative velocity of rain with respect to the man, we have to reverse the direction of the man, right? For example, we have relative velocity of rain with respect to man, which can be written as Vr minus Vm. Now reversing we can write it as Vr plus bracket minus velocity of man. In the order to find the resultant of the relative velocity of rain with respect to man, we have to complete the parallelogram and apply the law of parallelogram of addition. We find that square of the velocity of rain plus square of the magnitude of the velocity of man plus 2 into magnitude of velocity of rain into velocity of the man and the cos of the angle between these two. Since the rain is falling downward direction and the man is moving in the forward direction, we reverse the direction of the man and find the resultant velocity. The angle between these two, the velocity of rain and the velocity of man is 90 degrees. So cos 90 is 0 and we get Vr square plus Vm square under the root. Let theta is the angle between the resultant velocity and the velocity of the rain. So tangent theta is equal to BD upon OB in the triangle OBD. V is equal to Vm upon Vr. By knowing the value of velocity of man and velocity of r, we can find the value of the angle theta. So the man can protect himself from the rain by holding his umbrella at an angle theta with the vertical. Next, the swimmer river problem. Here, what is the shortest time taken by the swimmer to cross the river, and what is the shortest path taken by the swimmer to cross the river? We have to find the time and the shortest path. First, crossing the river in the shortest time. Suppose the swimmer swims with the velocity Vs, making the angle theta with AB. AB is the width of the river. Effective velocity of the for crossing. Here velocity is at the angle. So resolve the velocity in two components. One is the Vs sin theta, one is the Vs cos theta. Vs cos theta move the swimmer in the second side. So this is the effective value of the velocity. Now the time is equal to displacement upon velocity, and the velocity has the component Vs cos of theta. For the time t to be minimum, the factor Vs cos theta should be maximum. Means cos of theta should be maximum. Cos of theta is maximum when its value is 1 and angle of theta is equal to 0 degree. So the swimmer must swim in the direction perpendicular to cross the river in the shortest time. Next, when the swimmer tends to cross the river along the shortest path, suppose V is the velocity, V is the velocity, Vs is the velocity of swimmer, Vr is the velocity of river, and V is represented by the width. V is the swimmer moves in the direction of the resultant of the velocity Vs, and velocity of the river is V is equal to, we have to apply the Pythagoras theorem here. Vs square is equal to V square plus Vr square, and V equal to Vs square plus Vr square under the root. Time taken to cross the river is displacement upon velocity. Since displacement is s and velocity is Vs square minus Vr square under the root. Now we will do some problem based upon these topics. For example, a rain is falling vertically with the speed of 35 meters per second. A woman rides a bicycle with the speed of 12 meters per second from the east to west. Direction in which she should hold the umbrella. In which direction she should hold the umbrella? As we know, in the order to hold the umbrella, we have to find the relative velocity of rain with respect to the bicycle. So the umbrella should be held opposite to that angle, opposite to that of the relative velocity of rain with respect to the bicycle. So first of all, we have to calculate the relative velocity of rain with respect to bicycle, which is Vr minus Vv, can be written as velocity of rain plus bracket minus velocity of the bicycle. This is the vertical direction in which the rain is falling, and this is the direction in which the woman riding this bicycle. Now we have to reverse the direction of the velocity of bicycle and represent it by a OC. To find the relative velocity which is given by the diagonal of the parallelogram, right? Let theta is the angle between the rain and the resultant velocity, right? To find the angle, we take the tangent of theta and go in the triangle AOD. Tangent theta is velocity of V upon velocity of R, which is equal to 0.3429. Tangent theta is equal to 0.3429, and theta can be found by tangent inverse 0.3429. Go through the table of the tangent. We find the value of 0.3429. We get 18 degree 56 minute. So women should hold the umbrella at the angle 18 degree 56 minute in the order to protect itself from the rain. Second, a bus is moving due east and car is moving due to north with the same speed 50 km per hour. What is the absorbed speed of and the direction of the motion of car to the passenger in the bus? The velocity, the bus is moving due to east, due to east, and car is moving due to north. What is the observed speed of and the direction of the motion of car to the passenger? We have to find the relative velocity of car with respect to the bus. In the order to find the relative velocity of car with respect to bus, we have to reverse the direction of the velocity of bus and complete the parallelogram. In the order to complete the parallelogram, we have to find the resultant of the velocity, which is the magnitude of the velocity of car square plus square of the magnitude of velocity of the bus minus 2 magnitude of velocity of car, magnitude of the velocity of bus into cos of theta. Here theta is 90 degree and we get 50 root 2 by putting the values of velocity of car and the velocity of the bus. Now next question. Wind is blowing at a speed 70 km per hour and the flag is hoisted on the ship in the harbor flutter along the northeast direction. If ship starts moving at the speed 50 km per hour towards the north, then What will be the duration of the flag hoisted on the ship? Now, velocity of water is given 70 km per hour in the northeast direction, and velocity of ship is 50 km per hour due to north. So, draw a diagram. The velocity of ship is towards the north, and the velocity of water is given in the northeast direction. Northeast direction is that between the north and the east, which is at the 45-degree angle. Right? Now, we have to find the resultant velocity of the water with respect to the we have to find the velocity of wind with respect to the ship. In the order to find the velocity of wind with respect to ship, we have to reverse the direction of the ship. So reverse it in the downward direction, and the resultant of the velocity of wind with respect to the ship is given by the diagonal of the parallelogram, which is represented by OD. Now, let the resultant velocity of wind with respect to ship makes an angle alpha with the velocity of the wind. Now, the angle between the velocity of wind and velocity of the ship in the reverse direction is 135 degree, and the angle between the velocity of the wind and the resultant velocity will be the alpha. This angle will be alpha. Now, to find the tangent alpha, we have the formula Vs sin theta upon Vv plus Vs cos of theta. Vs is given 50 and sin theta is 135. Velocity of wind is 70 plus velocity of the ship is 50 cos of 135. Since in the order to solve these, we have to reduce the formulas sin 90 plus 45 and cos 90 plus 45. साइन के साथ अगर 90 डिग्री लगता है तो वो कॉस बन जाता है, इट बिकम्स द कॉस 45 एंड इट इज इन द सेकंड क्वाड्रेंट साइन इज पॉजिटिव. कॉस के साथ 90 है तो साइन 45 डिग्री. इन द सेकंड क्वाड्रेंट कॉस इज नेगेटिव, सो वी टेक द नेगेटिव साइन हियर. नाउ sin cos 45 is 1 upon under 2 and sin 45 is also 1 upon under 2, but this is with the negative sign, and we get 1.206. Tangent alpha is equal to 1.0206. Alpha is equal to tangent inverse of this angle, which is equal to the 45.5 degree. The flag will point nearly to the angle 45.5 degree. Next question is, a person rows a boat in the water with a speed of 4 meters per second. Water in the river is flowing with the speed of 2 meters per second. If the person rows the boat perpendicular to the direction of the flow, find the resultant velocity of the boat and the time taken by the boat to cross the river of the width 400 meters. Here, velocity of boat is 4 meters per second, velocity of water is 2 meters per second, angle is 90 degree and the width is given by 400 meters. Now, velocity of boat and the velocity of water both are at the 90 degree. Now the resultant will be given by the closing side of the triangle. We have to apply the triangle law of vector addition in order to find the resultant, which is the square of the magnitude of the velocity of boat plus square of the magnitude of the velocity of water plus 2 into magnitude of the velocity of boat into velocity of water cos of 90 degree. Velocity of r is equal to 4 square plus 2 square, which is under 20, and 4.472 meter per second. Now we have to find the angle alpha. We can find the value of angle alpha by putting the tangent alpha or sin alpha. It is convenient to take the sin alpha, so we find the trigonometric ratios for sin alpha. Velocity of the wind upon the velocity of the water upon the velocity of boat, which is 2 by 4 is equal to 1 by 2, and theta is equal to sin inverse 1 by 2. Sin की वैल्यू 1 by 2 कब होती है? At 30 degree angle. Now we have to find the time, which is the displacement upon velocity. Displacement is 400 meter upon velocity is 4 meter per second. So we get 100 second. That's all for today. Thank you.